You get extra credit, right?
Alright, so let's continue with this. This will be like part 3 or day 3 of this. We haven't been able to complete these notes. Hopefully today we'll be done. So let's look at this. Let's jump straight into it. What are they talking about in this problem? A cylindrical can, right? It tells us the radius is what? 10 millimeters. Is used to measure rainfall in Stormville. Ah, you get it? Stormville. Anyway, so it's called a rain gauge. I don't know if you guys ever seen a rain gauge. You have a ranch, or maybe you just want to know how much rain fell. You have it outside your house. But yeah, it's good to know how much water has fallen. So it says during the first 5 days of a 60-day period, 3 millimeters of rainfall had been collected. So do we already know how much was collected for those first 5 days? Yeah, how much was that? 3 millimeters, okay? It says the height of the water in the can is modeled by the function S. S of t is measured in millimeters and t is measured in days. So what does S of t represent? The height of the water in the can in what? Millimeters. Now specifically for 5 to what? To 60. So is it good from 0 to 5? No, okay. It's only good from 5 to 60. Do we need it from 0 to 5? Or do we already know the height from 0 to 5? Yeah, we already know that the height over the 5 days was 3. So we already know that. Alright. Now it also says the rate at which the height of the water is rising is given by S prime. Okay, so they're not telling us S, they're telling us who? S prime, right? And S prime only works from 5 to 60. It's the rate at which that water is rising. So depending on how much water went into it, how much water got out of it, it's going to help us. And yes, you forgot to get your calculator. So maybe like one person will get like, 4 or 5 for carry them over.
Thank you.
I got you.
Oh, thank you. Hey, why can you do it? I have a big thank you.
One day. Ahí se
Oh, I read something. And then I said, I read. Someone in the class.
Alright, so the first question here says, find the value of the integral from 10 to 15 of S prime. Using correct units, explain the meaning of this value in the context of the problem. So, how can I calculate the integral from 10 to 15 of S prime of t? Can I do that on my calculator? Alright, go ahead and go to your calculator. Type that in, and let's calculate it. See what we end up with. It's going to be negative?
Why do you mean negative?
Why would it be negative, right? It's describing the height, and the height should be increasing. Unless that like it's evaporating or something.
Just dumped it.
Or somebody hit it and it fell, right? Well, let's pretend that none of that happened. So type it in. Remember, you're using that function up there. You gotta make sure your calculators are in radians. Which they should be, unless your friends in other classes are switching them. That would be evil.
At 11.159.
11.159. And what would be the units of that? Millimeters, right? Because this is describing S, right? It would be like S of 15 minus S of 10, right? That's what that would be? Okay, so what is it describing in the context of the problem?
The amount of rain in the can after from T10 to T15.
The amount of rain in the can?
The height of the water.
The change in height.
The amount of change, right?
In the amount
In the height? The height. In the height of the water?
The amount of
Or
change.
of the height of the water?
The amount of change of the height, yeah.
Alright, so let me get you started.
Of the water.
This represents, so this isn't talking about the amount of water in there, because it's not a volume, right? It's not cubic millimeters or anything like that. So it's, remember, it represents the height, that's what S represents. So it's telling us the change in the height of the water in there, right, from that interval. So this represents the amount of change, right, of the height of the water in the can, in what units? In millimeters, from T equals 10 to T equals 15 what? Hours? Days. Pretty good? That tells us how much the height of the water changed from 10 to 15. The height increased, how much? 7.159 millimeters. Is that a lot?
Yeah.
That's pretty good for Laredo, right? This is Stormville.
I know, right?
I mean, if this is Stormville, I mean, it should be a pretty stormy town. I mean, if they name it after the storm.
Maybe it's supposed to be ironic.
Alright, so let's look at the next question. At the end of the 60-day period, what is the volume of the water? The volume of the water. Okay? That had accumulated in the can. Now they're not asking for the height of the water at the end of the 60 days. They want to know the volume of the water at the end of the 60 days. What shape is the can that we're working with? I need to know how to find the volume of a cylinder. Oh my God, all the way back to geometry. Big B times height.
Wow.
What does big B represent? Big base, right? Oh, the area of the base, right? And what shape is the base of that cylinder? So this is really pi r squared times height. Okay. So we know pi. Do we know r? 10 or 5? 10? Okay. Squared. What we don't know is the what? The height. Oh man. Can we figure out the height after the 60-day period? Yes? How could we figure out the height after the 60-day period? Okay. So what would be the integral that we could set up?
Integral S prime from.
The integral from 5 to 60? Oh, that's going to tell us how much the height changed from 5 to 60, right?
Yeah.
And what function would I put there? S prime, right? And I can use my calculator to get that number, okay? But that's not the change, that's not the height in the whole period, right?
60 minus 65.
We would have to add what? Add 3, right? Because the 3 would be from the first 5 days. So in the first 5 days, we were already at 3, right? And now I'm going to find out how much more it changed and add them together, and that'll tell me the height, right, of the water in the can. So figure this out in your calculator, 3 plus that, and what do we end up with? Do we understand where this 3 came from? 160 what? 166?
Yeah, 166.565.
And what would be my units? Millimeters? Millimeters cubed? Millimeters cubed.
Oh, no.
Oh, no.
Yeah, this is
Just
like-
millimeters,
yeah.
right? This is actually just the height, right? Okay, we still haven't found the volume, we're just trying to find the part that we're missing, right? So this is actually the height, right, of the water after the 60 days. So now we can go back up there and figure it out. So now we know that the volume is gonna be pi times 100 times 166.565. And on the AP test, we don't have to, go too far and multiply by pi. Actually, we could save some time and just leave the pi next to the number. So if I do this times 100, what would that mean? What do I do to the decimal? 2 times to the right, right? So this is actually 16,656.5 times what? Times pi. And then now it would be millimeters cubed, because now we're talking about what? This was millimeters squared, and this was millimeters, that gave me the millimeters cubed.
So science, let's say like we're running out of time, we just leave it like v is equal to pi times 100
I think technically you could.
You have to put just millimeters cubed.
Yeah, at the end, just put millimeters cubed. Or let's say you don't have the calculator anymore, right? So like this is a problem it would be in the calculator section, but you ran out of time and you didn't get to do that part. But you're already on the non-calculator section, you can go back, right? And continue working on those 2 questions that are calculator active, but you don't have it anymore. So that would be a way of getting around it and still getting the points. Cool? Alright, so let's look at the last one here. This one is talking about the rate at which people enter an auditorium for a concert is modeled by the function r, given by r of t is equal to this, for 0 to 2 hours. Okay, so what does this function represent? So this is a rate, right? It doesn't have a prime on it, it's not identified as a derivative or anything, but it is understood to be a rate. Yes, so technically it already is some derivative. They just labeled it r. Cool? Alright. And we're talking about hours, and it said r of t is measured in people per what? Hour. Now they said VIP tickets were sold to 100 people who are already in the auditorium when the doors open at t equals 0 for the general admission ticket holders. So I'm already inside. Sorry guys. So if I'm already inside, it means I'm a what?
Yeah.
I'm a VIP, you know what I'm saying? Okay? So, anyway, the doors close and the concert begins at t equals 2. So after 2 hours, nobody can go in anymore. Right? You lost your ticket. Sorry, too bad. Question says, if all the VIP ticket holders stayed for the start of the concert, how many people are in the auditorium when the concert begins? So how could we figure it out? Huh? Plus 100? So you want me to do the integral from 0 to what? To 2 of? R of t, okay. Not r prime? No? Why not r prime? Oh, because it's already a rate. Okay, good. Plus 100?
Yes.
Oh. So out of that, plus 100? What is this giving us here? So that's how many people went in from 0 to 2, right? And then this tells me the amount of people that were already in there that didn't leave, right? These are my VIPs. Okay, and that should equal the total, right? Amount of people in the concert from 0 to 2 hours. So tell me what that is. Go ninja, go ninja, go. I can do one of these tricks on my skateboards. Well, you tell me the answer, I can tell you which one. 1080? Yeah. I can do a couple of 1080s on my skateboard. No, not 1080s, just kidding. So 1080, what? People. So that's how many people have entered the concert or are at the concert in those 2 hours in that time interval. You understand? Cool? What if they told you that there was another function that represented the rate at which people were leaving during those 2 hours? How could I figure out the number of people in the 2 hours then? So it would be this, the amount that's entering, plus the 100 that were already there, minus the integral from 0 to 2 of the function that represents the rate at which people were leaving in that interval, okay? And there will be questions like that on the AP test. So you gotta take that into consideration and understand what the integral represents. That way you know what you're working with.
So it'd be like a two-part question where you find out one and then give you another question?
Not necessarily.
Or they would just
Yeah,
straight up say?
on last year's AP test, they did do it a two-part question. And one part of it, you could do it using the calculator. The other part, you had to do it using the table, which was a Riemann sum. And then you had to like put those two means together, which is pretty cool. This person did it, but he did it incorrectly. He did get a 5, but he still got that question wrong. So they described the problem in the first part. So it says water is being pumped into the tank at this rate, so that's the water that's going what? In, right, from 0 to 8. Water is removed from the tank at a rate modeled by R of T. Well, R of T is represented by this table up here. They didn't give me an equation for R of T. Cool? The first, they said there was how many in the tank already to begin with? 50,000. So to start off with, you're already at 50,000. First one says estimate R prime of 2. Should that be easy?
Yes.
Yes. Second question says use a left Riemann sum with 4 subintervals, right? Indicated by the table to estimate the total amount of water removed from the tank during the 8 hours. So this is like the integral of R of T, right? And they calculated that. That should be pretty easy to do as well. And when you get to part C, it says use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter at the end of the 8 hours.